Welcome to Maths and Science series. Today we'll be doing atomic combinations, but specifically the molecular shape. Okay, molecular shape. This is what we're going to do under chemistry, atomic combinations. Do not forget to subscribe, hit the notification bell so that you can be notified when we upload new lessons. Do not forget to share, like, and comment. After such a long time, guys, we haven't uploaded any lesson for you, but from today onwards we promise you that we're going to post or upload as many lessons as we can. So a molecular shape, it is this the shape that a single molecule has. So that's the definition for molecular shape. Now, as we are in this concept of molecular shape, there is a theory which we dealing with here in molecular shape, which is the valence shell electron per repulsion theory. So you must know this theory. Actually, maybe you know it as VSEPR theory. Therefore, the VSEPR theory is based on the idea that the geometry or the shape of a molecule is mostly determined by repulsion among the pairs of electrons around a central atom. So it is based on the idea of the shape that a single molecule has, in simplicity or in a simplified way. So there are steps you must know to determine the molecular shape of a molecule, if I can say or put it that way. So the first thing that you must know before you can determine the molecular shape of a molecule, you draw the molecule using a Lewis diagram. Then you make sure that you draw all the valence electrons around the molecule's central atom. That's the first rule. The second rule, you count the number of electron pairs around the central atom. So here in molecular shape, when we determine the molecular shape, we focus on the central atom after we've drawn or represented our molecule using the Lewis diagram. So that's very important. You will never know how to determine them if you do not know these steps. There are two definitions or terms that you must know. Bonding pair, two electrons shared between two atoms in a covalent bond. Then a lone pair, which is an unshared or unshared electrons. So we're going to talk about these two terms here in molecular shape. They are very important. Make sure that you know them. These 2 marks for bonding pair. They normally ask them in exams. Yeah, so that's very important, guys. Now let me show you how you see bonding pairs or lone pairs in a molecule after you have represented it with a Lewis dot diagram. Alright, this is the Lewis structure, Lewis diagram for H2O. So these 2 electrons that are paired here, they are known as pairs of electron or bonding pairs of electrons. And hope you understand that. So 1 electron of hydrogen, it is paired with 1 electron of oxygen, so they are known as bonding pairs. Now here then these are what lone pairs. We have 2 lone pairs, not 4. Each pair you count it once, not you will not say 1 2. So we have 2 bonding pairs and 2 lone pairs, not 4 lone pairs. We only have 2 lone pairs on this molecule. I hope you understand that. Let's see. Okay, NH3, ammonia. I want to show you how do you see lone pairs and bonding pairs. So this, it is the Lewis structure for ammonia. Now here we have 3 bonding pairs of electron. So we have the first bonding pair, because there's one electron that is paired with 1 electron of nitrogen. Then we have 3 bonding pairs of electron in this molecule. So that single one from the central atom is known as what? As a lone pair. So you check the bonding pairs, then you look if you have a lone pair on the central atom. So this is how you see bonding pairs and lone pairs. I hope we are together here. So this is very important because you can never determine the molecular shape without knowing this. So there's a table that you guys must know, this table. So we have number of bonding electron pairs, number of lone pairs, and the shape, which is the geometry. So it is very important that you know the number of electron pairs, how do you determine them, and the number of lone pairs, as we did in the previous lesson. So geometry, the shape, number of electron pairs, and number of lone pairs. Now, for you to have the geometry or the shape, you need to know the number of electrons paired and the number of lone pairs. Let me say the number of bonding pair, you have 1 or 2. Then when you check the number of lone pairs, then you get what? You get 0. It means that the shape of that molecule, it is linear. I hope we are together. Now, if you have the number of bonding pairs as 2 bonding pairs of electron, then the number of lone pairs, it is 2. It means that the shape of that molecule, it is bent or angular. So you can use 1. So number of bonding pairs, maybe you have 3 of them, then you have 0 lone pairs. It means that the shape of that molecule, it is trigonal planar or trigonal planar. Even on 3, 4, and 5, 6 as lone pairs, then you as a number of bonding pairs, then you check what? The number of lone pairs. They will give you the geometry or the shape, trigonal planar, if you have 3 bonding pairs of electron and 1 number of lone pairs. Okay, let's do an example. Determine the molecular shape of beryllium chloride, H2O, and ammonia. Remember, the first thing that you must do, you draw first what? Lewis diagram. Then you count all the bonding pairs, and do not forget again to do what? To count the lone pairs on the central atom. Since we have Cl2 and 1 Be, it means that Be, it is the central atom. Then Cl will surround Be. You draw first what? The Lewis diagram. You know that Be has 2 valence electrons, then Cl has 7 valence electrons. The first thing that you do, you draw the Lewis structure. Then we also have 7 valence electrons and Cl. Then we have we need to look at or determine the number of bonding pairs and lone pairs on the central atom. Now we have 1, 2 bonding pairs. These are bonding pairs or bonding pairs of electrons. Bonding pairs. So it's very important for you to know that. Now you check on the central atom if you have lone pair, the unshared electrons. So if you do not have them, it means that you have 0 lone pair, or the number of lone pairs, it is 0. Then you go back to that table. Now you have 2 bonding pairs and you have 0 lone pair. It means that the shape of this molecule, it has a linear shape. So it is very important for you to know that table. It's very important. Make sure that you know it. You're not going to be supplied with it in exam. So make sure that you know it by head or by heart. Then the first thing you do, draw the Lewis diagram, or you present H2O using Lewis diagram. Now O will be what? The central atom surrounded by two hydrogen atoms. Even if you can make it to be linear in shape. Alright, now we have 6 valence electron, now 1 valence electron in hydrogen. Therefore these are known as what? Bonding pairs. I hope now you getting these are bonding pairs. We have 2, not 4. We have 2 bonding pairs. Even here 1, 2, we have 2 bonding pairs, not 4 bonding pairs. Make sure that you understand what I'm saying. If you do not understand, make sure that you do what? You pause the video, then you listen. Then these are lone pairs. These are unshared electrons, which we call them lone pairs. So we have 2 lone pairs and 2 bonding pairs, not 4 lone pairs. We have 2 bonding pairs and 2 lone pairs. Therefore, when you check on that table, you get the shape of these of this molecule being bent or angular. So it is very important for you to know that table. So the shape of this, since we have bonding pairs, 2 bonding pairs and 2 lone pairs, it means that the geometry or the shape of this molecule, it is bent or you use angular. Say bent shape or angular shape, still one and the same thing. So you can never do this without knowing that table and the number of lone pairs and bonding pairs. Let us do ammonia. Let us determine the molecular shape of ammonia. So N will be the central atom. It will be surrounded with 3 hydrogen atoms. 3 hydrogen atoms. Now we have ammonia. You draw first what? The Lewis diagram. So make sure that the first thing you draw first the Lewis diagram or Lewis notation. We have 2, 3 bonding pairs. We have 3 bonding pairs, and on the central atom we have an unshared electrons, which is one lone pair, not 2 lone pairs. It's a 1 lone pair. Therefore, when you check on that table, you have 3 bonding pairs and 1 lone pair. It is known as the trigonal pyramidal. That's the shape of ammonia or NH3. I hope you understand this. You can pause it and listen to it again. So that's very important for you to know how to determine the molecular shape. Make sure you understand those 2 tips and steps, the ones that I gave you before doing this. All right, now there's a tip which you guys must know. We can also work out the molecular shape with double or triple bonds. To do this, we count the double or triple bonds as 1 pair of electrons. That's very important. If you have a double bond on that molecule or triple bond, count that double bond or triple bond as 1 pair of electrons. For an example, we did H2O. I just want to show you the type of covalent bond. Here we have a single bond. We have a single bond, this and this. Remember, copper structure. We have what it is known as single bonds. So in other words, we have 2 single bonds here. We have 2 single bonds. But we can also work out the molecular shape with double or triple bonds. Then what you must know is that you count that double bond or triple bonds as 1 pair of electron. So determine the molecular shape of carbon dioxide, CO2. We want to check what type of covalent bond are we going to have when we draw the Lewis structure for carbon dioxide. So it means there, since we have 2 oxygen atoms and 1 carbon atom, it means that C is going to be the central atom. Okay, this is how we're drawing what? The Lewis structure for CO2 or carbon dioxide. Remember, we have 6 valence electrons. What we did with that first oxygen atom, we must do it also on the second one. So here, if you can check, 1 2, this is a double bond. 1 2, it's a double bond. So in other words, we have 2 double bonds. But whenever we want to work out the molecular shape, we count this double bond as what? As a single or as one pair of electrons. So in other words, here we do not have 4 electron pairs, but we have 2 electron pairs or bonding pairs of electrons. We have 2, not 4. Remember, we take double bond as a single bond. Even if it was a triple bond, we'll take it as a single bond. Now on the central atom, we have 0 lone pair. The central atom is carbon. So you check on that table that the number of bonding pairs, it is 2, then 0 lone pair. It means that it is a Oh, sorry guys, it is not bent or angular. I made a mistake there. It is what? A linear, or it has a linear shape. Sorry about that. So it has a linear shape. Make sure that you correct that error. It is not bent. It will be bent if it had 2 bonding pairs and 2 lone pairs. I'm sorry about that. I hope you see my mistake. Alright, determine the molecular shape of HCN hydrogen cyanide. So as you can see here, we have a single bond and a triple bond. Remember, you count a triple bond as one bonding pair. So we have 1 bonding pair, and we count these 3 bonding pairs, or these 3 or triple bonds as 1 pair of electron. Therefore, here we have 2 bonding pairs. I hope you get this. So whenever you have a triple bond or a single bond, you count them as 1 bonding pair or electron pairs. So we have 2. Now when we check our central atom, our central atom is H, we have what? 0 lone pair. It means that this molecule has what? Has a linear shape. It has a linear shape. Remember that last one that I made a mistake saying it is bent or angular. I had to say linear. Sorry about that. Now let us okay, let me show you this thing of the triple bond. Let me say draw the Lewis structure for nitrogen gas. So whenever they say oxygen gas, remember it's O2. Fluorine gas is F2. Now this and this and that, so we have a triple bond, but you count them as 1 electron pair. So here in nitrogen gas, we have 1 electron pair. I hope you understand that. I was just showing the triple bond in this nitrogen atom. All right, HOCl. So they say determine the molecular shape of HOCl. Sorry, okay, here we have not H, it is OCl, chlorine. Then we have 6 valence electron oxygen. Then here we have 7 valence electrons. The valence electrons are electrons in the outermost of energy level, or the group number. Since it is written 17 on the periodic table, you take it as 7. Now these are bonding pairs. It means that we have 2 bonding pairs. So that's very important, guys, for you to know. Now we have lone pair. We check our central atom. These are unshared electrons, which we know them as lone pairs. So we have 2 lone pairs and 2 bonding pairs. So this is what? Bent or angular shapes, or it has a bent or angular shape. That's the shape of HOCl. So that's very important for you guys to know, before you can determine the molecular shape, you need to know the steps in that table. You must know how to determine the lone pairs and bonding pairs in that particular molecule. So make sure that you guys understand this. Thank you guys. So this was the last part of what we were doing. So now you can use your past papers to see that you understood what we were doing. Please do not forget to subscribe, like, and share. If you do that, we'll continue giving you lessons on bond length and bond energy, as well as intermolecular forces, electronegativity difference, and physics. Yes. All right. Thank you guys.